All right, so this question, this is a buffer problem, and this is really sort of the most difficult type of buffer problem I think that we typically encounter. It's a very classic problem though, I think, and really is very important that we understand all aspects of this problem. So let's go and get started. The first thing that I'm going to sort of point out here, I'm asked to create 100 milliliters, so that's going to be my volume, my total volume that I'm going to be using throughout the problem of a buffer solution. And the pH that I'm going to be shooting for is 9.55. So right away in that first sentence, I'm going to be thinking in my mind, I want to use the Henderson-Hasselbalch equation. This is really the easiest way to figure out what concentrations of base and acid, conjugate base, conjugate acid, I need to use in order to get a target pH, exactly of 9.55. So I'm going to need to know the Ka for NH4. I'm given that, so that will allow me to solve for the pKa. So really the ratio of base to acid, that's sort of what I'm looking for here. So you start by adding 5 milliliters, so I'm going to write that information over here. So I'm going to have 5.00 milliliters of 4.2 molar NH4 plus. And then I'm going to add to that 11.2 molar NH3. So in this problem, I'm given sort of a source of NH4 plus, which is my acid, and a source, so let's underline that. That's my acid. And then the NH3 solution, that's going to be my base. And I'm given this amount of NH4 plus. So with this information here, in my mind, what I'm going to be thinking of is, well, I can figure out how many moles, and therefore what my final molarity, my final concentration in 100 milliliters is going to be. So if we draw a little picture here, so this is my volumetric flask. So this is 100 milliliters. So right at that mark is going to be 100 milliliters. I'm going to put in, 5.00 milliliters of 4.2 molar NH4 plus. So this 4.2 molar, that is not my concentration of acid in my final buffer solution, right? That is my initial concentration, but my total final concentration is going to be based off of the 100 milliliters. So the first thing that I would probably do is use this information to figure out how many moles of NH4 plus that is. So if I wanted to sort of do that, I would type in 0.005, that's 5 milliliters, times 4.2. That equals 0.021 moles of NH4 plus. That's how many moles of NH4 plus I'm going to be putting in here. And then I'm going to dilute that essentially to 100 milliliters. So my concentration here, so if I wanted to divide that by 0.100 liters, that's going to give me my concentration of NH4 plus. So that equals 0.210 molarity NH4 plus. So this value, 0.210 molar, that's what's going to be my concentration of acid. So really have to make sure that we understand what's going on, right? So we're going to make this 100 milliliter solution, and this is how much I'm starting with, 5 milliliters of 4.2 molar, and then I'll figure out how many moles that is, and then dilute that to 100 milliliters to get this concentration. That's going to be my concentration in my full 100 milliliter solution. So at this point, I can start plugging some numbers in. My pH that I'm looking for, 9.55. My pKa, that's going to be the minus log of 5.62 times 10 to the minus 10th. It's a little bit messy there, but this is just this Ka value, plus the log of the concentration of base, which we don't know yet, over the concentration of acid. And that concentration of acid, that's going to be this 0.210. So I can sort of start to simplify this process. So if I get a value for this, this is equal to 9.25. Bring that over, I'm going to end up with 0.2996 equals the log of the concentration of base over 0.210. So putting this value in here for my concentration of acid. Then I'm going to take 10 to the power of both sides. So 10 to the power of this, 10 to the power of this. That's going to get rid of this log essentially. Then I end up with a value of 1.99 equals the concentration of base over 0.210. And now I can solve for that concentration of base. So therefore the concentration of base that I'm looking for should equal 0.4186 molar NH3. So this is really telling me this is what I'm shooting for. I'm shooting for a concentration of base of 0.4186 molar NH3. So now the question becomes, well, how do I get 0.4186 molar NH3 into this 100 milliliter solution? The first thing that I would do is I would figure out, well, how many moles is that going to be? In 100 milliliters, if this is my molarity, I multiply that by 0.100 liters, that's going to tell me that really what I'm looking for is 0.04186 moles of NH3. That's how many moles of NH3 I need to be in my solution here so that I end up with the correct pH. And if this is my number of moles, then how do I get that number of moles? Well, I'm given an 11.2 molar NH3 solution, and I want to figure out how much of that solution I'm going to need to take in order to get this number of moles. So if I take make sure you guys can see, 0.04186 moles of NH3, and I multiply that by 1 liter, has 11.2 moles, so this is just my molarity, right? Then I can find out that I'm going to need 0.003738 liters of that 11.2 molar solution, and this is equal to 3.74 milliliters. So to recap, if I want to make a 9.55 pH buffer solution, and I start by adding 5 milliliters of 4.2 molar NH4+, I can use the Henderson-Hasselbalch equation essentially to find what the ratio of base to acid is going to be. And really, it's going to be a 2-to-1 ratio. This 1.99 tells me I need essentially 2 molar base for every 1 molar acid I have. I can use that relationship to figure out, well, what would that be for the base? 0.4186 molar NH3. And then it just becomes a question of how do you make a 0.4186 molar NH3 solution if you're given this 11.2 molar stock solution. And the way you do that would be to take 3.74 milliliters of that solution. That's going to give you the correct number of moles. And then we just dilute that to 100 milliliters, and that will make the correct concentration in my buffer solution. So definitely an involved problem, a lot going on, but definitely something I would expect everyone to be able to do and really have a firm grasp of all the steps that we're doing here to figure this problem out. All right, let me know if you have any questions, and good luck studying.